Very good morning to dear students. In this class, we are going to discuss about the IoT physical devices. In this class, whatever the outline is building blocks of an IoT device, exemplary device Raspberry Pi interfaces, programming Raspberry Pi with Python, other devices. Those are needed in understanding IoT concepts with one important device Raspberry Pi and Python programming. What is an IoT device? Already we understand a thing of Internet of Things can be any object that has unique identifier and which can send or receive data over a network. IoT devices are connected to the Internet and send information about themselves or about their surroundings over a network or allow actuation upon the physical entities or environment around them remotely. IoT device examples. A home automation device allows remotely monitoring the status of appliances and controlling the appliances. Home related devices. An industrial machine which sends information about its operation and health monitoring data to a server. A car, automobile which sends information about its location to a cloud-based service. A wireless enabled wearable device that measures data about a person, such as the number of steps walked, and sends the data to cloud-based service. Sensors can be either on board the IoT device or attached to the device. Actuation. IoT devices can have various types of actuators attached that allow taking actions upon the physical entities in the vicinity of the device. Communication modules are responsible for sending collected data to other devices or cloud-based servers or storage and receiving data from other devices and commands from remote applications. Analysis and processing modules are responsible for making sense of the collected data. So, basic building blocks of an IoT device, again sensing, actuation, communication, analysis, processing. Block diagram of an IoT device. Here we observe that processor, graphics, connectivity and interfaces, storage interfaces, memory interfaces, audio, video. So these are the memory, storage and interfaces, and that is the connectivity, processor, graphics and audio, video. Exemplary device Raspberry Pi. Raspberry Pi is a low-cost mini computer with the physical size of credit card sized low-cost mini computer called as Raspberry. Raspberry Pi runs various flavors of Unix and can perform almost all tasks that a normal desktop computer can do. Raspberry Pi also allows interfacing sensors and actuators through the general purpose I/O pins. Since Raspberry Pi runs Linux operating system, it supports Python out of the box. Continuation. This is the diagrammatic presentation of Raspberry Pi. This is the board. In that we used, this is the CSI connected camera, Ethernet, USB 2.0, status LEDs, audio jack, RCA video, GPIO headers, DSI connector display, SD card slot, micro USB power, and HDMI. These are the components of the Raspberry Pi board. Linux on Raspberry Pi. Raspbian. Raspbian Linux is a Debian VZ port optimized for Raspberry Pi. Arc is an Arc Linux port for AMD devices. Fedora Linux is a Fedora Linux optimized for Raspberry Pi. And RaspBMC is an XBMC media center distribution for Raspberry Pi. OpenELEC is a fast and user-friendly XBMC media center distribution. RISC OS is a very fast and compact operating system. We can select any one of in our application. Raspberry Pi GPIO. It is the diagrammatic presentation. Just you observe. We cannot say every port, but you observe and refer the ports. Raspberry Pi interfaces. Serial. The serial interface on Raspberry Pi has receive and transmit or X and TX pins for communication with serial peripherals. SPI, Serial Peripheral Interface, is a synchronous serial data protocol used for communicating with one or more peripheral devices. And I2C interface pins on Raspberry Pi allow you to connect hardware modules. I2C interface allows synchronous data transfer with just two pins, SDA data line and SZL clock line. Interfacing LED and switch with Raspberry Pi. Here from time import sleep, this is the how we are interfacing the LED and switch with Raspberry. This is the logic we are using here. And while true, try if GPIO input 25 equals to true, toggle LED pin, sleep not one, except keyboard interrupt, exit. This is the little code part. Other devices along with the Raspberry Pi. PC, do you know? And BeagleBone Black, QB board, other IoT devices. So with the information by this slide, we conclude this class. Thank you for listening about the IoT devices. We will meet in the next class.